polymer structures, right? So polymers, you know, they are a kind of links or joints of a monomer. Monomer is a single unit, and polymer is a repetition of the same unit, right? So if you see what is a polymer is, poly means many, you know, right? Poly means many. Mer means repeating unit, right? Repeating unit. So a unit, one unit, which will repeat again and again to form a kind of bigger unit, right? Bigger unit. So here, see, if you see the first diagram, that is polyethylene, right? PE. If you see here, this CCHH, this blue highlighted part is there, no? This blue highlighted part is the repeat unit. So if you check throughout the polymer, you will have this C2H4. So this is C2, 1, 2C and 1, 2, 3, 4H is there, right? So this is one monomer, right? Monomer, I told you, is a one unit. Here also you have C2 and H4, that's 2C and 4H. Here also you can see 2C and 4H, right? Here also you can see 2C and 4H, right? So this 2C and 4H is the repeating unit, right? So you say, you, for example, this is monomer number 1, this is monomer number 2, and this is monomer number 3, right? So number of monomers, right? Number of monomers join together to form a polymer, right? Monomer, MONOMER. This is a single unit. So in the single unit, only this will come, 2C and 4H. Usually in the forthcoming slides, if it is H, I am not going to write like this, right? I'm not going to write like this. I will just stop with this. This is easy. Otherwise, I have to write H. Like if it is like 12H, then I have to write 12 H's. So I will simply stop with this, right? If I don't write anything here, you need to understand that is H. If there is any special thing, say for example chlorine, that I will write. All right. So let's come back to this polyethylene. This C2H4 is the monomer which is going to repeat again and again, right? So number of ethylene form together to make a chain, and it will form a kind of lengthier chain, right, which is called as poly of that particular monomer, right? That is polyethylene, or else polypropylene, right? Polyvinyl chloride, right? So that poly part is the indication for many, right? Many monomers combine to form a polymer. All right. And here we have the next diagram, right? This is polyvinyl chloride, PVC, right? We call it as PVC. So here you see, if this in this diagram, this blue shaded region is there, no? This is the monomer, right? This is the monomer. So which means 2C and 1, 2, 3H and 1 Cl is there, right? 2 carbons are there, 3 hydrogen is there, and 1 chlorine is there. So this is the monomer, right? This is the monomer. So in this blue shaded region, I have 2 carbon, 3 hydrogen and 1 chlorine. Here also, if I take 2 carbon, 3 hydrogen and 1 chlorine, this is again monomer. This side 2, 3 carbon, 1, 2 hydrogen, 1 chlorine, right? So these all are monomers, right? These all are monomers, right? So in this link we have 3 monomers. This complete link we have 3 monomers. Polyvinyl chloride, right? So the formula is C2, right? We have 2 carbon, H3, we have 3 hydrogen and 1 chlorine, right? So this is actually the, say for example, you don't have this blue color. So what I have is, see, I am writing this one, 1, 2, 3, 4, 5, 6, C and hydrogen. So I told you hydrogen I am not going to write. I will just indicate like this. Here for the easiness of writing with the cursor, I am just not writing the hydrogen, but from this diagram, right? Only from this diagram, not from the diagram below, right? If I ask, okay, since chlorine is already there, I will go for fluorine. Say for example, you are given with the structure like this. Now the question is to find the monomer of this unit. Okay, how to find, right? How to find. So in that case, you have to look at the chain, right? Look at the chain, and you need to find which unit is actually repeating, right? Which unit is actually repeating. So in this case, it's difficult. Okay, I'll say why. Because here you see it is C2 carbon, C2 carbon, C2 carbon, C2 carbon, C2 carbon. So you may assume that this unit is a repeating unit, isn't it? You can do that, right? You can do that. But in this and this, in this diagram and this diagram, you don't need to get confused. Why? Clearly it's showing this is a monomer, 2 carbon, 3 hydrogen and a fluorine, right? Even without the blue shade, you can identify. Okay, if you see this unit is being repeated, right? 2 carbon, 3 hydrogen and fluorine, 2 carbon, 3 hydrogen, fluorine, 2 carbon, 3 hydrogen, fluorine, right? So this is the repeating unit, right? So this is how we will find the monomer from a given polymer, all right? So ancient polymer history, originally natural polymers were used, right? Natural polymers in the ancient time. Wood, cotton, leather, rubber, wool, silk, these all are polymers, right? These all are polymers. Wood is a polymer, cotton is a polymer, leather is a polymer, right? One of the oldest known uses is rubber balls used by Incas. So Inca is a race of people. It is being said they use rubber balls. So this slide is just to emphasize the usage of polymer from the ancient time. Without giving it the name polymer and all, they actually has used it. Silk, you know, they used it for dress. Wool is also something like that. Rubber for slippers, leather again for slippers, cotton for clothes and dress, wood for these furnitures and all, right? So the usage of polymer is there from the ancient time. Only thing is they don't give the name polymer. So polymer is not a like newly invented thing. The name polymer is a newly invented thing, right? They have used polymers from the ancient time. Then the later stage only it is bring into the structure. Okay, right. Polymer composition. Most polymers are hydrocarbons, right? So among this said wood, cotton, leather, rubber, wool, silk, usually most of the polymers are hydrocarbons. So what are hydrocarbons are? That will have hydrogen and that will have carbon, right? That will have hydrogen and that will have carbon. So if you take any polymer, the most of the composition will be carbon and hydrogen. So if you want to make it as a kind of percentage, right? So say for example, you have PVC, polyvinyl chloride. So in that you have chlorine, hydrogen, carbon and chlorine, right? So if you want to separate it based on percentage, right? Then you will find that is chlorine would be of around 20%, but the hydrogen and carbon is the 80%, right? So that's what it said. Most polymers are hydrocarbons. H and C would be the major constituents in a polymer, in a composition, right? In a polymer composition. There can be others also, chlorine, fluorine, oxygen, H. So these all will be there, can be there, but only this H and C form the major part of this constituent, right? Then we come to saturated hydrocarbons, right? So now you need to recall the valence number of the carbon. Periodic table, carbon is coming in 4th tiers, right? Hydrogen, HHG, here lithium, first one, beryllium, second one, boron, third one, and carbon, fourth one. Then you have nitrogen, oxygen, these all will be there. My concern is only about carbon now, right? So this is first group, second group, third group, and fourth group. So carbon is in fourth group, right? Nitrogen, oxygen, H3, fluorine, and neon will be there. That's fine. We are not going to go to that neon part now, right? We will stop only with the carbon. So now the valency of carbon is 4, right? You know that, which means it can form only 4 bonds, right? Carbon can form only 4 bonds since it is in the fourth group, 1, 2, 3, and 4. Right? Since it's in the fourth group, valency is 4, which means it can form only 4 bonds, right? Now we will take this carbon, right? So this carbon has 1, 2, 3, and 4 bonds, right? So now this carbon has 4 bonds. If I take about this carbon, this has 1, 2, 3, and 4 bonds. All right, this has 4 bonds. I told you carbon can form maximum of only 4 bonds, right? So saturated hydrocarbon means each carbon bonded to 4 other atoms, right? It is bonded to 4 other atoms. All right. So here with this hydrocarbon, one is bonded with hydrogen, the other one is also bonded with hydrogen, third one is also bonded with hydrogen, the fourth one is bonded with the carbon, right? Similarly, if you take this carbon, first one is bonded with that hydrogen, this one is bonded with this hydrogen, this one is bonded with this hydrogen, and here is bonded with the carbon. So there are 1, 2, 3, and 4 bonds. If I take this carbon, 1, 2, 3, and 4 bonds, right? So if each carbon atom bonded to 4 other atoms, which is said as saturated hydrocarbon, which means it's full. We can't introduce any more bonds, right? We can't introduce any more bonds. So 4 other atoms are the important part here, right? If it is bonded with 4 atoms, we can't add more bonds. So this is given by the formula CnH2n plus 2, right? Saturated hydrocarbons can be given in the formula CnH2n plus 2, right? So say for example, I will put n is equal to 1, right? I'll put n is equal to 1. C into Cn, so that is 1C H 2n plus 2. So I need to put 1. So 2 into 1, 2 plus 2, that is 4, right? That is 4. So that will be giving you CH4, that is known as methane, right? You know that CH4 is known as methane. Okay, I will put n is equal to 2. All right, I'll put n is equal to 2. In that case, I will replace this n with 2, C2, right? C2 H. I will put this 2 here. So 2 into 2, 4, plus 2, 6, right? C2 H6, C2 H6. This is known as ethane, right? This is known as ethane. In the similar way, if you put n is equal to 3, if you put n is equal to 3, so C3 n is equal to 3, H, that is 2 into 3 plus 2, that is H8, right? So C3H8 is called as propane. Right? Similarly, you can keep on increasing the number of n and replacing with this formula, you will be getting different composites, right? So if you put 4, you will get C4H10, that is known as butane. Then if you put 5, you will be getting C5H12, that is pentane. Like that, it will be keep on increasing, right? So if the all bonds are bonded with other 4 atoms, it is called as saturated hydrocarbons, right? So we should have 4 atoms around a particular carbon atom, then that is saturated hydrocarbon. This is just like after replacing with these numbers. So CH4 is methane. This is a structure, and the boiling point is also given minus 184 degrees Celsius, right? Then ethane C2H4, sorry, C2H6. This is a structure C2 1 2 3 4 5 6, and boiling point is 88 minus 88. Sorry. Propane I have C3H8 1 2 3 1, 2, 3, 4, 5, 6, 7, 8. Right. So that will boil at 42, minus 42 degrees Celsius. Then I have butane, C4H10, right? Due to lack of space, it will be drawn. And this boiling point is minus 0.5. Pentane, C5H12, 36.1 plus. Hexane, C6H14, that is 69 degrees Celsius. So this will keep on going, right? So the naming is probably based on the available, I think, Latino or Roman system. So meth, ETH mean 2, prop mean 3, but mean 4, pent mean 5. Pentagon, you remember? Pentagon, pent mean 5. Hexagon, 6, so hex means 6. Heptagon, HEPT, that is 7, right? HEPT, hexane is 7. Then I have OCT, octane, that is 8. Then it's nonane, that is 9. Decane, 10. So this will keep on going, right? So when you increase the number of carbons, automatically this H will also increase based on that formula, CnH2n plus 2, right? So accordingly, boiling point will also increase with the increase of the number of carbons, right? With the increase of the number of carbons, boiling point will also, if you see, increasing. Okay, now I have unsaturated hydrocarbons. In the previous last slide, you saw saturated hydrocarbons. Now we are going to see unsaturated hydrocarbons. Double and triple bonds relatively react, can form new bonds. So the hydrocarbons which have double bond or triple bond are known as unsaturated hydrocarbons, right? If you see, comparing to that previous definition, I told you each carbon atom should attach with 4 atoms, then that is called as saturated. Here if you take this carbon atom, here I have 1 atom, 2 atom, 3. It is joined with only 3. So there is a possibility it can form another bond, right? There is a possibility. But in case of those hydrocarbons which I have shown already, they cannot form extra bonds because all 4 are already filled. But here you see, it has now only 3 molecules, it can form a 4th molecule. If I take this carbon, it has joined only with this carbon and this hydrogen. So only 2. This is bond number 1, this is bond number 2. But I told you it can have bonds with 4 carbon, not 4 carbons, 4 atoms, right? So in that case, what will happen? This bond and this bond will be broken for creating a single bond, right? Single bond. So if you see here, just with the help of the diagram, you can see the double bond, right? So here we have 2 bonds, that's why it is called as double bond. 1 bond, 2 bond, right? And here, if you see, we can see that is triple bond, 3 bonds, bond 1, bond 2, bond 3, right? That is triple bond, right? What will happen is when these double bonds or these triple bonds are there, we can break them to form bonds, right? So say for example, I have this triple bond, right? What I can do is I can break it to form another bond. So here if you take this carbon, right? If you take this carbon, it has bond 1, 2, 3 and 4 bonds. It has 4 bonds, right? You need to understand this is 4 bonds, not 4 atoms, right? This is only 2 atoms but 4 bonds. Here only 3 atoms but only 3 atoms but 4 bonds, right? So saturated, you see, if you see, that is 4 atoms as well as 4 bonds, right? So bonds are anyhow going to be same throughout, 4 bonds, but the atoms are going to be, the number of atoms are going to be changed, right? Either we can have 2 atoms or 3 atoms or 4 atoms. So what I was saying is, say for example this one, so we just 2 carbon and hydrogen, right? 2 hydrogen, this is fine. So now if you check in this diagram, right, in the diagram shown by them, I have 1, 2, 3, 4 bonds there, right? Here also 1, 2, 3, 4 bonds is there, fine. but in the diagram which I have drawn now, I have only 1, 2, and 3 bonds for this carbon, right? So what I have done is I have broken a joint which is actually been here, right? This bond was actually there, but I broke it. After breaking, what can I do is I can add anything else. Say for example, I am willing to add chlorine, right? I am willing to add chlorine, so we can add chlorine, right? So now if we check 1, 2, 3, 4 bonds are 4, fine, but again the number of atoms are 1, 2, and 3, right? So you need to remember double bonds will have 3 atoms. It can have 4 bonds, right? Triple bonds have 2 atoms, but again 4 bonds. Single bond has 4 atoms as well as 4 bonds, right? So number of bond is always going to be same if it is a stable component, but the number of atoms are changing here, right? Now we'll see what is about this unsaturation. So if the bonds can be broken to form a new component, that is known as the unsaturated component. Right? So here it was C2H2, right? 2 carbon and 2 hydrogen, C2H2. But what happened when I put this fluorine is, just an example, this one bond is broken to accept that chlorine. This bond is broken to accept that chlorine. So with that broken bond, so now I had 3 bonds, it's broken to 2. So now what we have is C2H2Cl2. This is after breaking one bond. But story is not ended here. We have another bond, right? We have 2 bonds. So we can break one more bond also, right? So what I can do is I will break this bond also. So if I break this bond, I will have something here and I will have something here, right? So in this I can say, for example, I will add F, right? I will add F. So actually I need to show this is only one bond. I am adding F here also. I am adding F, right? So if you take this carbon now, it has 1, 2, 3, and 4 bonds, right? That is fine. This carbon also 1, 2, 3, 4. 4 bonds are there. But if you check now, 4 bonds are there. 4 bonds are always there. Number of atoms, this carbon has, right? This carbon has 1 fluorine, 1 hydrogen, and 1 chlorine. That is 3 plus 1 carbon. That is 4 bonds. If I take this carbon, which is connected with carbon number 1, hydrogen number 1, fluorine number 1, and chlorine number 1. So that is totally 4, right? 4 atoms. We can simply join by breaking the bonds. So this is why the compounds or hydrocarbons which has 2 bond and 3 bond, that is double bond and triple bond, are said as unsaturated hydrocarbons, right? Unsaturation means you can break the bonds if it is necessary to form a saturated hydrocarbon. In the case of previous one, that is 4 bonds and 4 atoms, right? So there you can't do anything. You can't add, though you can remove, or you can't do anything. But in this case, you have double bond, so you can break it, right? You can break it to form the single, what is this? Single bond, right? So this is what known as such unsaturated hydrocarbons. So unsaturated of anything, not only hydrocarbon, unsaturated hydrocarbons means hydrocarbons which have double and triple bond, right? So double and triple bonds are relatively reactive and can form new bonds. So why these are forming bond is these double and triple bonds are kind of reactive. So they have tendency to react. They are willing to react. So similar case here, if it is single bond, that will not go much into this reaction thing. But if it has double or triple bond, that will definitely go on reaction to break up this bond, right? Break up this bond and to join new people on that, right? So double bond is ethylene or ethylene. So here's a double bond. Give an example. This is ethylene, right? Ethylene. Similarly here, that is C2H2, that is ethine, right? So you need to be very careful in, while naming also, right? The previous one, that is C2H6. So which is coming in the formula C2H2, I mean C2 CnH2n plus 2, right? I'm talking about that formula, that is C2H6. This is known as ethane, ethane. All right. And I have the other component C2H4, right? C2H4, that is this one. All right. So this has a formula of C2H2n, right? This has a formula of C2H2n. This is known as ethylene or ethene, right? This is known as, easy to compare if I write it as ethene, ATHENE. All right. Then I have this component which can be written as C2H2. This can be written as ethine. So here the formula is C2H2n minus 2. So the first case C2H2n plus 2, then it is C2H2n, then it is C2H2n minus 2, right? And while naming, you see this is ethane, ETHANE. Only one letter is different, right? So this one ETHANE, ethane. And this one C2H4, this is known as ethene, ETHENE, right? ETHENE. Only the fourth letter is being changed, but that's a complete change of the structure. And the third one, that is C2H2n minus 2, this is ethine, ETHY. Only the fourth letter is changing. See, ETH is fine, AN is also fine, but only the fourth letter is changing, A, E, and Y. So if it is unsaturated, only ethine and ethene will come into picture. If it is saturated, ethane will come into picture, right? So this is AN, EN, and IN part is common for all the bonds. Not only for the ethane, it's for propane also the same, butane also it's same, pentane also it's same, right? So PR, OP, propane, right? Other one, PROP, ENE, that is propene. And the third one, YNE, right? YNE, that is propine, right? Propane, propene, and propine. So they are aligning with these formulas, right? So if it is propane, not propane, if it is AN, that is CnH2n plus 2. If it is EN, that is CnH2n. If it is IN, then that is CnH2n minus 2. All right. So this is all about naming as well as the saturation, unsaturation of these hydrocarbons, right? So from here onwards, you must be able to understand saturated means all bonds are filled and single bonds. Unsaturated means all bonds are filled, but they are double or triple bonds which can be broken to form new components, right? This is unsaturated hydrocarbons. Then we will now move to isomerism. If what is isomerism? Isomerism means two compounds with same chemical formula can have quite different structures. Sorry, quite different structures. These are called as isomers, right? So isomerism is this event. Isomer is they have same formula but different in structure, right? These are known as isomers, right? Isomerism, two compounds with same chemical formula, right? Same chemical formula can have quite different structures, right? So formula is same, only the structure is different, right? We will take this example. All right, we will take this example. Okay, CH18. Okay, so this is now going to be the formula. Okay, CH18 is the formula, right? This C8H18 we can write in different forms, right? So those different forms are shown here. This way, if you see 3, 6, 8C and 8 plus 8, 16, 17, 18C. This is fine, right? This is C8H18. This one also C8H18, right? Why? Here it's drawn, here it's shown just by writing. So CH3, CH2, 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 again 2 CH2, 1 CH2, 2 CH2s, CH3, right? So here you see 1, 2, 3, 4, 5, 6, 7, 8 carbons are there, right? So I can write C8. Hydrogen is to C3 plus 2, 5, plus 2, 7, plus 2, 9, plus 2, 11, plus 2, 13, plus 2, 15, and plus 3, 18. So this can also be written as CH818. So now our formula is, or structure is a CH8H18. Now we are looking at how to represent that C8H18. What are the capable ways? Okay, this way also you can write. Another way, here is also another way, right? CH3, CH2 6 times CH3, right? So this is what I show you in the second slide. I think we'll put a bracket, then we'll put a line, which means it is a polymer. So here if you see CH3, CH2 bracket 6 times. So 6 times we are going to write CH2, 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 CH2. So this can be compressed to this format to reduce the time spending on writing all this stuff, right? So now this is CH3, CH2 6 times CH3. So if you see here, carbon, 1 carbon, 6 into 1, 6 carbons, plus 1, 7, plus 1, 8 carbon is there, C8, right? H. So here 2 into 6, 12H, right? H2 into 6, that is 12H. 12 plus 3, 15, 15 plus 3, 18, that is 18, right? That is C8H18. This one is C8H18. And then I have 2-methyl 4-ethyl pentane, right? 2-methyl 4-ethyl pentane. Now we will see that. So in this structure, if I see 1, 2, 3, 4, 5, 6, 7, 8, 8 carbon is there. 8 carbon is there. If I count the number of hydrogen, right, I have 3 plus 2, 3 plus 3, 6, 7, 8, 9, 10, and plus 3, 13, plus 2, 15, plus 3, 18. That is C8H18, right? So now the component is C8H18. We can have number of different ways to write that. Okay, we have number of different ways to write that. This is also CHH18. This is also CHH18. This is also CHH18, and this one also CHH18. Right. So these are different ways of writing the same formula, right? Same chemical formula. CHH18 is the formula. Also, you need to take very care while drawing this stuff. A carbon can have maximum of only 4 bonds. Huh? So if I take randomly a carbon, say for example this carbon which has 1, 2, 3, and 4 bonds. It can have only maximum 4 bonds. Okay, so you need to check that one also while writing these things. And now we will see why their name is kind of different. 2-methyl 4-ethyl pentane, right? There is a naming system. Okay, there is a standard naming system. So that is very standard. Say for example, if I say this is 10, right? Everywhere in the world this is 10. Sri Lanka this is 10, in Nepal that is 13, Australia this is 17, not like that. 10 means 10 everywhere. So that's a kind of standard, right? So here also the case is same. We need to write what is the name of this one in a standard form. Okay, so for that only there is a number of guidelines. If it is not in a like single chain, right? So this is a single chain, I can say you. This is also single chain. Here also single chain. But this is not single chain. This is a kind of branch. So you see here there's a branch. Here also there is a branch, right? So this is not single chain. This is branch. So in case of this one, no problem. You just have to write a number of carbon, so you will be easily identifying the name. But here you need to look at of first the numbering of the carbons. So I will start from here: 1, 2, 3, 4, 5. Right. So I have numbered the carbon atoms in the very main chain. This and this are subchains or branches, which I am not going to number now. Right. After numbering this, what we will do is, in the second carbon atom, one CH3 is there, right? So CH4, I told you the name is methane, right? CH4, I told the name is methane. So if it is CH3 bond, CH3, so we will write this, right? So this is also a bond, but we don't know how and when is it going to be bond. So we will commonly write this like this, right? So this is equal to C. This bond I don't know where to connect, right? There is an H. Here is an H. Here is also an H. Right? 1H, 2H, 3H. Right? So this is not bond. This is equal. All right. So these three are fixed, all 3H. But this one I don't know when and where to connect. So we'll keep it as like that, right? That will automatically go and connect. So this is why it is called as methyl, right? CH4 mean methane, CH3 minus mean methyl. So this one is called as methyl, right? So methyl group is in second carbon, right? It is joined in the second carbon. So we will start numbering as like 2 methyl. In carbon number 2 there is a methyl, and then with the main link. So 2C and 1, 2, 3, 4, 5. This will be empty. So by this bond, this is joined with this, right? So if you take this fourth atom, this C2H5, that is ethyl, CH2, CH3, this ethyl group is there in the fourth carbon atom, right? So there, then we will see 2 methyl, 4 ethyl. In fourth carbon, ethyl group is there, right? In second carbon, methyl group is there. 2 methyl, 4 ethyl, pentane, right? So now you can write octane. It means usually octane, but now you can write octane by, because this CH3 is already there as a methyl. So that is 1. Methyl mean 1, no, meth mean 1. Then this CH2 CH3, this is being as 2 carbon and 5 hydrogen. So that is ethyl, right? That is ethyl. So methyl mean I said 1, ethyl mean I said 2, right? So now 1 and 2 is altogether 3, right? Then I have this pentane part. So that pentane is 1, 2, 3, 4, 5 carbons you have, though that's why this is pentane, right? You have 5 carbon atoms, that's why it is pentane. All right. So that's why this is pentane. 2 methyl, 4 ethyl, pentane. All right. So we are not going to call this sample as octane. Why? If you take the name, methane mean 1 plus ethane mean 2 plus, right? So I'm just talking from the name, right? 2 methyl, meth mean 1 plus 4 ethyl. In the fourth carbon there is ethyl, ethyl mean 2 carbon, right? That is 2 plus what is this? Pentane, right? So in pent I told you that is 5 carbons. If there is 5 carbons, that is pentane. right? So if you add together 1 plus 2 is 3, 3 plus 5 is 8, right? So here also you have 8 carbon, here also you have 8 carbon, right? So that's why we call this as 2-methyl 4-ethyl pentane. We do not call it as 2-ethyl 4-methyl 2-methyl 4-ethyl octane. We are not going to call like that, right? So if this methyl and ethyl part, if you have separately told them as 2-methyl and 4-ethyl, we are not going to add their number of name in the this one, right? Main chain. So if they have branches, we will name the branch separately and the chain name separately, right? Right. So now we will see how these polymers are forming, right? We have seen what is a polymer and what is a formula, but we didn't see how is it forming, the mechanism. All right. We see now how the formation of the polymer is happening. First one, free radical polymerization, right? So this is called as free radical polymerization. I told you most of the time the polymers, I mean this, hydrocarbons are, polymers are hydrocarbons. C and H would be there most of the time, right? And here you see this is monomer. So by the name monomer, you understand that this unit is going to repeat again and again, right? This unit is going to repeat again and again. And the name is ethylene, right? I told you, if it is double bond, then it is ene. If it is triple bond, then ine. If it is single bond, then ane, right? So now there's a double bond, then that is ethylene, okay? Ene. This is a monomer. And here I have a something called free radical, right? This R. So usually this free radical is noted by R. This R can be of any atom which is going to join with. It can be Cl minus, it can be F minus, right? Or it can even be bromine, Br minus. So whatever the part which is going to join actually with this monomer is what called as a radical. So as a common, right, we denote this as R, right? So based on the need, you can put it as fluorino, bromino, adeno, fluorino, whatever it is, right? Commonly, which is known as R. Right? That is free radical. That is R. So this R combined with this monomer will give you C2H4 into R, right? So now we have 2C, here also 2C, that's fine. Here 4H, 4H, that's also fine. Here I have double bond, but here I have single bond, and the other double bond which is being broken by this R to join with it. So this double bond is broken and formed between this R and the C. Okay. So this picture is this picture. C2, H4, one bond is broken to join with R, right? And we will have a dot here, right? This dot here. Why? Because this carbon has 1, 2, 3, 4 joints, that's fine. 4 bonds. But this carbon has 1, 2, 3 bonds, only 3 bonds. So there is a space for another molecule or atom to join with. So to denote that, we will put this dot, right? This is a dot. So here also in R, usually we put the dot, right? Which means it is ready to join. And this is the initiation stage. So what will happen? There will be a monomer, there will be a free radical, it can be of any of the atom, and that will go and break this monomer's one joint to form a bond with it. All right, this is the initiation stage, that is first step. Then in the propagation, this component, right, this so formed component C2H4R, right, this so formed component plus this monomer, right, this monomer will form the next lengthy chain, right? Because monomer, I told you, this is the repetition unit. All right, this is a repetition unit. So with this is going to join. So how will it join? There is a dot, there is a double bond, right? So this double bond will break to join with this dot. So this will form a bond like this. So which will be coming C4, right? C4 H8, right? H8 R and a dot, right? Why there's a dot now? That dot will now transfer here. Okay. So if you see all these three, that is 4 bonds are there. But in the last one, this carbon, that is only 1, 2, 3 bonds, right? And that's why I have a dot here. I'll send you. Right, that's why I have a dot there. Right, this is propagation stage. Right, this is propagation stage. And this is another component, right, for simple example. Okay, so there will be an initiation stage where the radical bombard with the monomer to form a joint, right? That's a bond. Then that monomer, right, combined with radical, that particle will create bonds with the forecoming monomers, right? So there is a dot. So in the next stage, what will happen? Another monomer of this one will join with this. So I will add plus 2C plus 4H. So 2 more carbon, 4 more H. So that will be like this. 2 more carbons, 4 more hydrogen, and there will be a dot, right, for the next monomer to add, right? So this is how this reaction will propagate. All right. So the next one is also an example, benzyl peroxide, right? So the first diagram which you are seeing is the benzyl peroxide. Okay. So here we have shown you how the radical go and make a bond with the monomer. Here we are showing how will it bond is broken. So you see here, this one and this one is same. This CH2, this CH2 is there, O is there. So we can say this is the repeating unit, right? C2 benzene O. Sorry, not C2, CH2 benzene O. Similarly, here I have CH2 benzene O, right? So this is a repetition unit. So here you see we have 2 of this one, right? This is 1, this is 2. 2 of benzene is there, CH2 is there, O is there, right? So what will happen if I break this bond is I will have a dot there, right? If I break the bond, that is not complete now. Then I have to put a dot. If there is a dot, then I will be having what? 2 radicals, right? So if it is a radical, that will be having a dot, right? Which means it is ready to go and make a bond, right? So this altogether can be considered as a radical, right? This is a radical. So I told you radical can be of anything, a chlorine or fluorine or benzene, right? Anything can be a radical. So now 2 into R dot. So this all is considered as R and there's a dot, right? 2 R dot. All right. Right. So this is a kind of illustration of how is it looking like. So this I already told you, repetition unit, right? This is a repetition unit. In 3D, it will look like this. So this one, this center one is carbon, and these are hydrogen. So this particular molecule is being drawn here, right? So these are carbons, right? These sorry, not these are carbon, these are hydrogen. These white things are hydrogens, and these ash color things are carbons, right? Polyethylene is just a long HC, right? Polythene, you see, say this bag is there, no polythene bag. That is a just a long HC, a long hydrocarbon, right? So I don't know how many hydrocarbons are there, but if you put like number of hydrocarbons, that will give you polythene. Again, paraffin is short polythene, right? You might have seen this paraffin also. That paraffin is a short polythene. All right. Now we have different names, right? So I have shown you now how is the formation, initiation, and everything. Now we'll see what are the names of these polymers. First one, polyethylene, right? So that I already told you, C2H4, right? So this is actually, you see, a repetition unit, right? This is the repetition unit. So if you want to write it exactly as polymer, you should write like this. So this is the way you write for polymer, right? What is already shown here is the monomer, repeat unit, right? And then I have PVC, right? PVC. So that is C2H3Cl, or else you can write CH3CH2Cl. If it is monomer, then this is the unit. If it is polymer, then you need to write like this. Then I have polytetrafluoroethylene, PTFE, polytetrafluoroethylene. That's why it is PTFE. So there I have 2 carbon and 4 fluorines, right? 2 carbon and 4 fluorines. Why 4 fluorine? Tetrafluoro. Tetra means 4. So this is tetrahedron. So tetra means 4. So tetrafluoro, fluoro, that is fluorine 1, 2, 3, 4. Ethylene. Ethylene means 2 carbon should be there. We have 2 carbon, right? So you don't need to memorize this, right? Simply by understanding, you can write the name, right? Simply by understanding, you can write the name. So this one, poly anyhow, it's going to come. Tetrafluoro, 4 fluorine is there, that's why tetrafluoro. 2 carbon is there, that's why it's ethylene, right? And next, polypropylene, right? Polypropylene. I told you prop means 3, then 3 carbons must be there. 1, 2, 3, right? Polypropylene, 3 carbons should be there. Then I have 3 plus 3, 6 hydrogen, right? Polypropylene. So these are these short notations. PE is polyethylene, PVC polyvinyl chloride, PTFE polytetrafluoroethylene, PP polypropylene. Then I have polystyrene, right? Then I have polystyrene. So this is the monomer of the styrene, right? Styrene means that must have a benzene and C2H3, right? C2H3. This is what called styrene, right? If it is N number, then that is polystyrene. This is known as PS, right? Polystyrene. Then I have polymethyl methacrylate, PMMA, right? So this is the monomer of that unit, right? Then I have phenol formaldehyde, right? This has another name, bakelite, right? So this has a unit. There's a benzene and 3CH2 and the OH. So usually for phenol is only this much, right? Phenol is a benzene and then OH minus. Only this much is what called as female, so not female, phenol, right? And when you add 3CH2 for this bond, it is known as phenol formaldehyde. Then I have polyhexamethylene adipamide or nylon 66. So this is your non-technical word, nylon 66. Right? Nylon everyone know, right? Nylon rope everyone knows. All right. So why it is nylon 66? Because nylon is a component formed by 6 of this side component and 6 of this side component, right? So this unit 4, 5, 6. So this is 6 CH2 4 times CWH both side, right? And this one CH2 6 times NH2, right? So here I have 6 carbon, here also I have 6 carbon. So when these two sections joined, I have nylon 6,6. So that's why it is known as nylon 6,6, 2,6. Sorry, hexamethylene adipamide, right? Hexamethylene, right? Hexamethylene adipamide. 6 methyl. Hex mean I told you 6, right? Hex is 6. Methylene, 1 carbon mean methylene. Amide. Amide usually we go for we say for the solutions which have N as a component, right? Nitrogen, if it is there, then we call it as amide, right? And this is a kind of acid, COO. Here we have OH minus, so that OH minus actually removed. So that's why this is known as nylon 6,6, right? Then I have polyethylene tetraphthalate, right? PET, a kind of polyester, right? So these are actually resins, not resins actually. This is a kind of fiber, amide. Here polyester, this is a resin, right? Polycarbonate, this is again a resin, right? So these are few examples for polymers. Then I have this molecular weight, right? Mass of a mole of chains, right? So if you see these chains, there are two chains. So this and this, these are two chains. So this is actually each this kind of dot is indicating a monomer, right? Each this square type of dot is indicating a monomer. So when the number of monomers increases, right, the chain will be large. If the number of monomers are low, the chain will be low, right? So total weight of polymer over total number of molecules, right? So this is what called as molecular weight. Total weight of polymer, right? So this is the total weight of the polymer upon total number of molecules. So this one is a all molecules, right? So the usually the molecular weight versus amount of polymer will take a kind of graph like this, right? Covalent chains, molecular structures. First one, there are different types of chains, right? First one, linear. Okay, linear. So probably we will have like a kind of carbon, 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 like this, right? Maybe we will have hydrogen, hydrogen, hydrogen. So this is what called linear, right? If I have a polymer like this will come under this category. All right. Then branch, right? Branch. So if you see, for example, the one I told, like 2-methyl 4-ethyl pentane, right? So 2-methyl 4-ethyl. So here you see there is a branch, right? There's a branch. Here is also a branch. Here is also a branch. So these components are like this. It's just an example. It does not need to be only CH3. It can be CF3 or whatever it is. I'm just showing it for the purpose of branches. So this one does not have any branch. This is completely linear. But here it does have branch. You see, these are branches. And there are polymers which are cross-linked, right? Cross-linked. So those polymers will have a structure of, then maybe this carbon would be joined with this carbon. Maybe this and this will join. Okay, this will form like this, right? So cross-linked. It is linked in between that component, right? So there are different type of these fibers. Natural fibers actually are there. Okay. If you want to just check with the environment, you just those who live in singular regions, single areas, you guys should go and check with the Nava of, right, the bark of the Nava tree, right, bark of the Nava tree. And those who live in this Tamil area, you guys go and check with this papo tree, right? Papo tree itself, died papo tree. Okay, so there you will find these kind of cross-linked structures. Those who have interest, just go and see. So single area people, you go and check with the Nava tree. fiber and bark. Actually, bark. Fiber, it's not going to come as fiber. The bark, you need to cut it and separate it to see. And those who live in Tamil area, you just go and see the papo tree, not living papo tree, a died papo tree. Okay. So they will have this kind of structures. Then I have network, right? So network, it is like high strength, right? So strength wise, this is first, this is second, this is third, this is fourth. So strength is decreasing this way, so the strength is increasing this way, direction of increasing strength. So from linear to branch to cross-linked network, it is strength is increasing this way, right? So network mean usually this phenolic content, benzene and other things, they all will form this network, right? So if you want to know what is benzene and all, I think I have already shown. Still, so these kind of things, right? This is a benzene, this is a benzene, right? Phenol, if I have an OH. So these kind of bonds, right? I'm not talking about this structure. You need to be very careful. I'm not talking about this structure. I'm talking about this structure, right? This particular bond. So this is actually C, 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 and C. 6 carbons are there. So this is the actual structure. So that for the easiness and standardness, we will write like this. Okay. This is actually this and this are equal. All right. And then we will have an H. Right. We will have an H. All right. And then I will have a bond between this. Okay. So now you see, you check for each carbon. I will take example this carbon. Okay. 1, 2, 3, 4 bonds. Fine. I will take this carbon. 1, 2, 3, 4 bonds. Fine. I will take this carbon. 1, 2, 3, 4 bonds. So if you check any of this carbon, that will have 4 bonds, right? But the thing is, this double bond can be broken if it is necessary, right? But usually this double bond will not be broken, right? And that's why they are high in strength, right? That's why they are high in strength. You see, then branched cross-linked strength. Then the cross-linked network is actually strength. So this is the maximum strength, right? So this is the reason there are double bonds. If it is necessary, it can be broken, but usually it will not broken, right? So that's why strength is high for these type of molecules, right? These type of molecules. So there was a diagram I already show you about how will they take the shape, right? Yeah, so this is how it will take the shape, and I think, yeah, there's a proof. So this is the rough sketch of how will it look like. So now I am going to show the same thing in a 3D view, right? So just remember, these are carbon, right? These all are carbon, and these all are hydrogen, right? These all are hydrogen. Now here again, these all are carbon, right? These all are carbon, and this one is the physical area or physical volume which is covered by these 3 hydrogens, right? So one hydrogen would be here, one would be here, and the other one would be here, right? So this is a normal area which is covered, not area, sorry, volume which is covered by the polymer, right? So molecular orientation can be changed by rotation around the bonds, no bond breaking needed. So this is a linear kind of structure. If you bend it, that will bend, right? No problem. So if you just imagine a polythene bag, you can take a polythene bag, and if you fold it, that will be folded. No? So that's the thing. So they can be changing the direction without breaking the bonds. Molecular shape, right? So there is something called stereoisomerism, right? Stereoisomerism. If you break into 2 words, so otherwise you will face difficulty in pronunciation. This is stereoisomerism. All right, which means same molecule, right? Same molecule, but it will look like you place a mirror in between. If you place a mirror, so say for example, you are standing in front of a mirror, your right side will look like left side and left side will look like right side, right? So similar scenario here, this is stereoisomerism. So what I have is C2H3R, right? This R can be a ClO, FO, whatever it is. That's a double bond, right? So you know, while breaking the double bond, we will put something like this in both the sides and we will break the double bond. There will be not double bond, there will be only single bond, right? So this is this. You see, C2 is there, H3 is also there, R is also there, and double bonds, right? Oh, you can write the same thing in the other way, right? You place a mirror, right? You place a mirror this way. I place a mirror this way. So what will happen? These two will be here, these two H will be here, these two carbon will be here, and this R will go there, and this H will also go there, right? So this and this are similar things. You see, two carbon, two H, one H and one R, one H and one R. So if you place a mirror here, you will have structure like this. Okay. In a similar way, you place a mirror here, right? You place a mirror here. So A will be there, this E will be here, this B will be here, and this B will be there, right? So same structure taking different orientation is known as stereoisomerism, right? Stereoisomerism. And also, if you look at this diagram, so there are two strange lines and two kind of different lines. Did you observe? These two are kind of similar lines and these two are even different. The reason is, right, this is a 3D model, right? The previous slide I show you, this is a 3D thing. So this in nature, you see, in nature this will hold a volume, not a line. Right? In nature this will hold a volume. Volume means that is 3D, right? In 3D, if I draw all the lines as same like this, how do I know where is it standing? Maybe it is staying in this plane. Maybe this R is not in this plane and it may be inside this plane. Maybe this H is not in this plane but maybe in front of this plane, right? So these things are possible since it is taking a volume. So this is to show that, right? So one of this is to show it is staying before, I mean in front of the screen. One is to show it is in the back of the screen. These two are not in this plane of the screen, right? A, B and D, E are not on same plane. A and B may be on same plane. E and D are not on the plane. So either it may be E on the back of the plane and D on the top of the plane, or on the other hand, that has a particular reference, right? To if it is going inwards, it is staying in front or inside. If it is going outwards, so there are standard reference for that, right? How to draw the arrow mark for denoting the plane. This is why we have lines, different lines. Okay. This is how the molecular shape and the stereoisomerism is. Stereoisomerism means you place a mirror in front and how will it look like? This is what called stereoisomerism. Right? Tacticity. Right? This is another term. Tacticity. Tacticity means stereo regularity of the strain. The previous one you see stereo isomerism. Here this is stereo regularity. So how regular the chain is arranged. Isotactic, right? Isotactic, which means all R groups on the same side of the chain. What is R? R can be anything, a chlorine or fluorine or bromine or phenol or benzene, whatever it can be. So if all the R groups are on the same side of the chain, so this is the chain, right? This is a chain. This is one side of the chain. This is other side of the chain. If all the R groups on the same side of the chain, this is called as isotactic, right? This is called as isotactic. If R groups all in alternative sites. So one are here, other are here, third are here, next are here, right? If it is like this is known as syndiotactic, right? Syndiotactic. R groups are on the alternate sides of the chain. All right. Then I have atactic, right? Not atactic. This is atactic. R groups are random, right? So this does not have any regular pattern for these R groups, right? R groups are this chlorine or fluorine, whatever it is. This does not have any regular pattern. These are randomly arranged, right? So one R here, another R here. You see here another R. Here we have the next R, right? So these radicals, free radicals, are arranged in a random manner. That is known as atactic, right? So tacticity is the stereo regularity of the chain, right? Then I have cis trans isomerism. In isomerism, you have already seen stereoisomerism, right? This is stereoisomerism. Here, this is cis trans isomerism, right? Don't confuse with that too. First, we'll see what is cis. Bulky groups on the same side of the chain, right? Bulky groups are on the same side of the chain. If you take this one, right, this particular component, this is a bulky one, right? Why? We don't know what is actually there, right? Since that is a line, right? Since this is a line, we need to interpret that there is a kind of a chain, right? We don't know how big is that. Okay, so this is the bulky group. Similar case here also, since there's a line, there should be a chain. We don't know what is that, but there should be a chain, right? It cannot be a ClO FO, a single component. It cannot be. There must be a chain, right? But if you see here, that's complete. CH3, fine. There's no line, so there's no chain. And here also, that is H, right? Now we come to the definition. Bulky groups on the same side of the chain. So I told you, chain, this is chain. Bulky groups mean big groups. So big groups are on the same side of the chain. Big groups are on the same side of the chain. And small groups are on the other side of the chain. This is known as cis isomerism, right? This is known as cis isomerism. So here cis isoprene, natural rubber. So this is natural rubber. Huh? We'll see what is trans is bulky groups on opposite side of the chain. So I told you, since it has a line, so this is a kind of bulky group. Since this also have a line, this is also another chain. I told you this is a line, all right, the line. So here, this bulky group and this bulky group are on the opposite sides of the chain, right? This is a chain, this is one side, this is the other side, right? Also, this and this are small groups. They are automatically going to be on the opposite side of the chain, right? Trans isomerism, the balance is a little bit good, right? The both the sides we have bulk groups and the small groups, but in cis isomerism, only on the same side we are having the big molecules or big chains, right? So this is what called as cis isomerism, and this is known as trans isomerism. This is the definition. Then we have copolymers. Two or more monomers polymerized together, right? Two or more monomers polymerized together. So far we have seen a monomer repeating again and again, right? A monomer repeating again and again. But here, two monomers. So in the first one, if you see, there's a black and red, right? Both color dots are there. So if those blocks, dots are arranged randomly, so you see here 3 red, then 2 black, then 2 red, 1 black. So this is randomly arranged, right? A and B randomly vary in chain, right? So copolymers mean if in copolymers random chain mean if more than 2 monomers are there and if they are varying randomly, that is known as random variation, right? And then I have alternating copolymer, right? So alternating copolymer mean by the name black red, black red, black red. You see, it's alternating, right? So A and B alternate in polymer chain, right? So if both of them are alternating in the polymer chain, that is alternating polymer. All right. Then I have block. Third one, you see block. So that is 4 black, then 5 red, then 5 black, then 5 red, something like that. That's a kind of bulk, right? So this is known as block, right? Block copolymer. So what's the difference between block and random copolymer? Block means that even if it is varying 5 and 4 and 3, that would be as a block. You can't find the 1 or 2. If you see that's 5, then 5, then 5, 4, 3, something like that, you will find. But in the case of random, that can be 1, 2, 3 would be there. Even 1 would be there. But in the case of block, 1 would not be there. 1 and 2 will not be there, right? So these are known as block copolymers, right? Then I have graft, right? Graft copolymer. The graft copolymer, the main polymer will be there, right? The main monomer will be there. But the other one, we have two types now, A and B. One will be there, the other one, B, will be as a kind of branches. This is kind of joined, right? Joined in between. So chains of B grafted onto the backbone.